And thanks a lot to all of you for joining this online webinar. It's really good to see such strong interest around this topic. And I will guess that this new normal will only make you and us more important, to make hygiene, efficiency, and sustainability more relevant. My name is Erik Fossum Farævaag, and I'm the founder and president of Disruptive Technologies. We're a Norwegian company with background from microchip design originally and digital transceiver radios. So we're kind of proud to have been taking the world wireless the last 15 years. And I'm here together with the CEO of Infogrid. So Will, feel free to introduce yourself.
Hi, everybody. So I'm going to speak a little bit later on in more depth, but really a pleasure to be here, and thanks all for joining.
In short, Infogrid is a very strongly recommended partner of Disruptive that delivers a tool to help facilities management, basically with their unsolved problems. So when we have a challenge out in the field, we actually usually call Infogrid. So very thankful to have you with us today, Will. And in this presentation, I will start and spend just some minutes with a broader IoT overview, because I think that puts this into perspective. And then talk a little bit about Disruptive, and then we'll talk specifically about these applications and some use cases there. Occupancy, smart cleaning, and Legionella. And then we'll have about 10 minutes of Q&A. But first, I would like to spend a couple of minutes on where we are today, and put this all into perspective, this whole IoT world and where it's heading, because I think that background is quite important. So when you use your computer or your device, you basically connect to a computer far, far away over another place. That computer over there is usually many computers nowadays, and we call that a cloud. That is as simple as it is, but it's still one cloud. But what is starting to happen now is that these clouds also connect together to deliver you value. So how will this look in a few years? Well, it's already beginning to start, but today we're basically in the center of this slide. So there is some AI, there is dashboarding, there is analytics, there are some assistants. But what is happening now is that there becomes more and more clouds. It becomes clouds that are just context cloud, knowing about other clouds. There's going to be output clouds, which represent cars, screens, loudspeakers, and so on. There will even be clouds that represent services. Other clouds will represent the devices around us. And we in Disruptive, we represent the input device. And so by detecting something out in the field, you can analyze that, and you can make actionable insight and close the loop automatically. So if you heard about Industry 4.0 and the IoT, this is it, and that is us. We represent the input to the system. Our vision is to sense the real world everywhere and to deliver insights anywhere. And we do that by providing these small stamp-sized, they're actually stamp-sized wireless IoT sensors that you can place anywhere, literally. And there are some true benefits by our system compared to others that we're very proud of. One is that it's very simple to start using. It's prepared. So there's no commissioning, no pairing, there's nothing. Actually, when you receive the sensor in the mail, before you get the mail, you see that the sensor report into your system. They roam with all the gateways. We call that cloud connectors, so that if you want to increase range or you want more redundancy into your system, you basically just add more gateways. Battery lifetime, even though these are always on and reports always on the cloud, it has 15 years of battery lifetime. It's unprecedented. Very flexible integration, goes very fast, with typically 15 to 20 minutes for a simple webhook integration. We have an aggressive pricing scheme that also our partners have, and this small size is beneficial in many ways, also in terms of quality of the system and in the speed of installation. I'll come back to security, but these are also designed for scale. So you can start very small and even if you want 10,000 or 50,000 sensors in one installation, it's no problem. There is no upper limit. Whereas we see other places, other competitors, there might be some upper limits at 200 and 500 sensors even. So what sensor types do we have? Well, touch, basically just pressing this is one. We also have this with tactile feedback so that you get a click. Temperature, very accurate temperature and very responsive. So you can blow on it and you see the temperature curve coming. Proximity, detecting if the door and window is open or closed, so if it's empty for the toilet, the paper dispenser is empty, you can detect that with a proximity sensor. Water detector to detect if there's a leakage or if there's water or not. Somewhere, maybe flush rate and so on in toilets. And humidity, relative humidity of air. So that also allows for a lot of different applications. Since we're a technology company, we have kind of built it mostly from ground up. We built the semiconductor ourselves. We built a radio protocol ourselves, the cloud protocol, which is the same, which makes it simpler for you, and a very scalable cloud infrastructure, and with end-to-end security. And we have our own manufacturing line in Germany that we own ourselves as well. So it's been a massive project, and we're very proud of that as well. System overview, these small sensors report to cloud connectors. There's no buttons on the cloud connectors. There's actually no buttons on the sensors either. But when you touch it, it pops up in the dashboard. So that's how you know what sensors you're talking to. And that cloud connector reports to our cloud and then pipe that towards the partner's cloud. And then there's an application, in this case from Infogrid. And security really matters. You might think that this is more important on the cloud tools and the personal information, but the more sensors you have, the more you know about a building or an installation. So we've taken this to the outer edge. You can actually deliver us your encryption keys, and even we cannot see that in the data from the sensors. It makes it a little bit cumbersome, but that's another thing. And so it's true end-to-end, from the sensor all the way to it leaves the cloud again. And in our last security review, we got all A's. And this is actually by Praetorian. So, and we are the top 5 companies that they ever tested. So the security is really, really high focus from us. And for a solution with us from A to Z, that's a challenge. 2 options to start using Disruptive, and that is either to use our DT Studio, which is a very, very simple interface with some graphs and but the very comprehensive API, simple still, or you integrate with one of our partners, and that's why I brought Will from Infogrid here today. You can start today very small, just by buying a starter kit, and then you can scale infinitely across the world with our solution. So I also added a discount code here for you to know. It's just valid for a few days, but feel free to buy a starter kit and start test yourself, or connect to us or Will afterwards. So that was it from me. Over to you, Will, from Infogrid, to talk about occupancy, smart cleaning, and Legionella. And I saw you said that you're not as handsome as me, but at least you're more intelligent, Will. So
I think there's a strong case for debating that. But yeah, really a pleasure. Thank you, Erik, and thank you for that really, really informative summary there. And also, I'm sure we can all agree, not only is Erik very handsome, but his environment from which he's presenting is incredible. That is actually his own dining room. That is not a Zoom background.
Thanks, Will, but it looks better than it is. But it is real. It is real.
There we go. Perfect. So what Erik's done is given us a really great summary of how the DT equipment works, and I'll come on to this in a bit more detail, but it really is best in class, and the simplicity, the scalability, and the low cost are critical here. So Erik, we go to the next slide. So what we've seen in Infogrid is that consistently across the built environment, there's a real problem, and that is a data black hole. So whereas in the rest of our lives, everything we do online, everything we do in our cars, with our phones, etc., It's well documented, tracked, and used to improve the services that are given to us. Actually, in the built environment, be that an office, a hospital, a school, you name it, there's a real lack of good quality, not only real time, but any data at all. And where it does exist, say in a BMS, it's very limited, might be getting overwritten every so often, or held proprietarily by one of those companies. So this leads to a lack of data, and that in turn leads to a lot of manual work and a lot of increased risk as a result. So people going and physically checking things, filling in paper check sheets, going and counting the number of people in an office, monitoring fridges, Legionella checks, you name it. So this is
actually how it is.
Yeah.
I was amazed by that. This is still the case, but it actually is how it is.
And there's a really clear reason for this. So when I started asking various different companies why they weren't embracing Internet Things sort of 3 years ago, the answer that came back was remarkably consistent. It was that it was either too complicated, too expensive, or usually both of those things to move over. So there was a kind of a real inertia about doing anything. And that is just such a solvable problem that Infogrid and DT together are answering. So if we go on to the next slide, Erik. So the critical piece here is that this is technology for the non-technical. It is not technology just for the sake of technology. What we realized was a lot of these problems, they have multifaceted users. So yes, you need high quality data at an organization-wide level, and you can use that to make very smart, informed decisions, from better rotoring to utilization or even acquiring of space. But actually, your non-technical users on the ground, the security guards, nurses, cleaners, they also need to be able to use this to generate the most possible value from the system. So it has to be something that is intuitive for someone with no technical background and requires no training at all to use, but then creating that powerful data at a macro level. And that's where the combination of Infogrid and DT really helps to solve real world problems, because it is as simple as peel and stick and then ultra intuitive software. And that means you can retrofit any type of existing asset in literally seconds to make it a smart asset, and start using that to solve point solutions, to create point solutions, to fix problems, rather than something that's just a generic tool set. So that can yield things like timely alerts for problems as they arise, and then also retrospective analytics to change your operations as you go. And we go into a few specific examples of those in a minute. But if we go to the next slide, please, Erik. So here, before I go into a few of the use cases, I thought it would help to show some actual outcomes. So in recent months, we've been working a lot with the National Health Service here in the UK in the sort of post-COVID environment, but we have also been working with them for several years before. This is all around automating as much as we can in terms of places that are taking up nurses' time with daily manual checks. So this could be checking a fridge temperature or a cupboard temperature for pharmaceutical storage, which is being done every single day by a human, taking 15 minutes per fridge per day, automated immediately with a sensor, ROI within literally months. This could be bed occupancy, space utilization, Legionella checks, you name it. It's taking those tasks that are really creating a lot of drain on people, automating them so they can go back to their core jobs. In this instance, putting people back on the front line for care. Some other outcomes include helping businesses to avoid buying new space because they felt like they were being told that their office was full, but actually they didn't feel like it was being fully utilized. So understanding that utilization data helped them to avoid purchasing a whole nother building. An 81% reduction in labor requirements for Legionella checks. Smart feedback panels, whether in bathrooms or elsewhere, at a seventh of the cost of alternatives. And £100,000 saving across just 3 buildings from a smart cleaning setup. So real tangible outcomes, and very, very quickly indeed. So if we go to the next slide, Erik. Very quickly on how tech works. So Erik has touched on the sensors and the cloud connector. And as he mentioned, it then goes on to the cloud, the partner cloud being our Infogrid cloud. And you can use that data how you will. So you own that data, you've got control over it. And it can either go into our applications for point solutions, and I'll talk about those in a minute, or you can put it into your own internal system if you've got a corporate system you'd like to use, or indeed a third party. What we're doing our side is pushing this data through machine learning to make it relevant to those use cases, but that processed output is available via a fully open API as well as our application. Super versatile, very simple. Next slide, please, Erik. So really broad range of different use cases, and unfortunately don't have time to go into them all right now, but very happy to field questions in the Q&A or in follow-ups afterwards. So today we're just going to focus in on 3 of them: smart cleaning, Legionella, and occupancy, which are all quite pertinent in the sort of post-COVID environment, which I know is on a lot of people's minds at the moment. So if we go to the next slide, please, Erik. So if I start with occupancy, so this is based off of the Disruptive Technologies temperature sensor. It's super small, very, very unintrusive. So you can see a picture of it there. The kind of thing that people aren't going to even necessarily notice is there. And if they do, it just looks like a temperature sensor. So it's not going to cause people any concerns around privacy, because all that's being captured is a temperature reading. We've then done that through machine learning our side, that understands the specific environment to that particular sensor and tells us whether or not somebody is there. So you just get an output of occupied or unoccupied, which gives you the ability to generate sort of powerful analytics. A couple of point examples on the right there, but a lot more possible. So things like average occupancy over time, heat maps of when space is being used. You can set up an entire office in hours. So we've done over 1,000 sensors with a team of 2 in 3 hours. It's so simple that anybody can do this.
What was that number, Will? Can you repeat? What was that number?
So over 1,000 sensors in 3 hours with 2 people. This could be anybody. This could be your on-site team. You don't need to get specialist installers in, so that keeps costs low. And of course, we provide consultancy about how to best achieve that. And then this can be used for a range of different things. So poor occupancy for better use of space, and carbon savings for shutting down areas that aren't being used, but also social distancing and usage-based cleaning. So if I know a desk or conference room or certain area has been used, then I can correlate that to a specific clean afterwards. And likewise, if I know it hasn't been used, then I can save that time in not having it cleaned. This is giving us a healthier, lower cost workspace, and critically can also be integrated with third-party systems if you've got internal tools.
I would also like to say to you, Will, that I personally was very, very skeptical about using temperature sensor on this before. I actually said to the sales in Disruptive that this is not something that we should focus on. But what happened was that Infogrid kind of proved that it was very reliable, or at least much more reliable than much of what exists out there. And I think now the precision is becoming really, really good. So now this is one of our main applications, I would say, even though the sensors were not designed for it. But we as humans emit radiation, and there's some temperature radiation, and there's some degrees of change on a small sensor like ours, and that makes Infogrid able to detect it.
Perfect. Yeah, and just to point that out, so that is the machine learning element. So there is not a desk occupancy sensor from DT. You would need to work with us to generate that use. Next slide. Perfect. So the next one is smart cleaning. So a little bit linked to the last one in terms of occupancy. Mercifully, it's not me that's installing that urinal sensor in the bottom right-hand corner, but just to show the versatility there. So again, utilizing the simplicity and low cost and scalability of that DT hardware with intelligence our side, that then has usage-based cleaning. So, for example, understand if particular bathrooms or even particular stalls or urinals are being used, clean them on a usage base. So I want to clean them to go after 25 uses of the bathroom instead of a fixed rota, say every 4 hours, allowing you to deliver a much better quality of service with either fewer or the same staff then acting in a sort of roaming capability. Typically seeing an ROI of less than 3 months on this helps you to generate sort of your post-COVID diligence and a much better satisfaction rate. So where you're being asked to deliver a higher quality of clean with the same staff, this allows you to be more dynamic. And then also track sentiment with feedback panels to see actually how your customers are responding to this. And we're seeing very consistent increase in satisfaction. Last use case, if we could, perfect, is monitoring. So this is for your regular flushing and temperature checks for Legionella. So typically people are going and running these taps, putting a manual probe into them, depending on the environment. That could be daily, weekly, or monthly. This is now being done every 5 minutes by a sensor. So significantly higher quality of data. It's tracking the temperature of water inside that pipe with an offset, and also looking, again, using some machine learning at whether or not there's been water moving events, sending you alerts if there haven't been, and then critically automatically generating the report that would be filled in by hand. So there's a little snapshot of what that kind of looks like in the middle there. Super, super simple to set up, just cable tying to the outside of a pipe, massively reducing labor costs, as I say, typically 81%. ROI of less than 6 months. Huge amount of carbon saved as well, because you're not flushing hot water that's been heated with gas down the sink. You're not sending people out in cars to go and do jets, and a huge amount of water saved as well. So we've seen a huge amount of interest in that. Can't go into any more use cases now because we're a bit out of time. So just go to the next slide, please. Erik, just to say, it's a combination of that ease of use, affordability, and scalability. So one of the questions I think that's coming up later is, I've got a large estate. How easy is it to roll this out broadly across that? Incredibly easy. We use something called the 10-click principle, which is setting up 10,000 sensors with no one individual having to do more than 10 clicks. I'm very, very happy to talk to that later. And then last slide, please, Erik. So just to say that if you do want to get in contact, please do. Very happy to answer questions now, as is Erik, and then our door is always open, as you see on the sensor going forward. Really, really happy, and thank you for letting me.
Perfect. Well, thank you very much, Will and Erik, for that presentation and for walking us through everything. We do have a couple of questions that came through. One question that I would like to start off with, though, is on some of the previous slides, the one where you were talking about occupancy sensors. Just to confirm, you're using the temperature sensor to determine occupancy. And given kind of current, I guess, perceptions of privacy and everything, how this is not using video or some other type of thing to capture people and to capture personal information, was that a consideration when you guys moved forward to use the temperature sensors for this?
Absolutely. So we've seen actually a couple of high-profile cases of systems that are very, very specific, tracking people's loo breaks, for example, or camera-mounted solutions that are actually capturing images, have a significant amount of pushback from people in that space, and understandably so. So the point here is the only data point being captured from that space is a change in temperature. So this is either in degrees or Fahrenheit, that is by its nature not private information. Now, how you set that up your side, you could theoretically name that sensor as specific to a desk, or you can not. But all it's going to give you is this particular asset, that could be a desk or something else, being utilized, for how long and at what times. But because that sensor is typically reading every 5 minutes, what you're not doing is tracking every second that somebody gets up to go grab a coffee or goes to the loo or something like that. You are looking at utilization in those blocks. So a lot less sensitive around that information, but giving you the kind of critical steer that you need to clean a space that's been used, or mark a desk as occupied for a period on a floor plan, or understand, okay, am I actually getting 100% utilization of this space, or is it actually only really busy on Mondays because that's when everyone has their meetings, and if we just do a bit of a reshuffle, we can make much better use of the space, particularly in a social distancing environment. And so we've worked with clients to, for example, correlate this with meeting booking calendars to see, okay, has the space been used as much as it was booked for, or give very granular kind of breakdowns by time and day and so on. So it's very dynamic, but deliberetely designed not to intrude on people's privacy.
It's been tremendous. It's fair to say that there's been tremendous interest about this, Will, the last time.
Yeah, so consistently over the last couple of years.
I would say it was luck that we actually hit this use case, because it was not, and it was not at all intentional, but it seemed to work really, really well. And I think that's thanks to Infogrid that had built these algorithms on top. It's from us, it's just a simple temperature sensor. That's what it is.
Perfect. I think we've got a few more questions, so I won't dwell too long, just conscious of time.
Yep. So I think you mentioned one of the questions earlier. How can I monitor my whole portfolio across multiple cities? And also the second part of that question, do I have to install a gateway at each property and then feed them into my software manually?
So you will need gateways in each property, just because, so this system works on cellular, so critically you don't have to touch the local network, which is a real benefit from an IT security perspective.
But everything is included in the price. So there's a full solution included in the price. You don't need to think about SIM cards or operations or anything, or that the system is down, it's on us.
Yeah, the cellular is included in that subscription, but you will need a hub for each site. That said, it's so simple that it's just a case of plug and go. Now, I don't have time to go into it now, but if you want to get in touch afterwards, I can give a really quick demo of just how easy it is to manage a very large estate. What we do is a nested folder structure where you can set permissions down to an individual sensor or site, but have that kind of working like a family tree. So you'd have your overall team at the top, and then breaking down into sort of regions, sub-regions, cities, buildings, even floors or rooms in that building. So it's really, really simple to use that through a very consolidated tool, and you won't need to do any manual uploads. That all gets done immediately as you order. So please do get in touch afterwards for a more thorough demo, but very simple is the short answer.
Yeah, cool. And then I'd say the next question is, can I integrate gateways into all other software as well? And do your gateways have APIs to work in other European countries and with other providers?
So the answer is yes on all fronts. So there are two options here. If you want any of those kind of use case specific solutions, then that's with us. We process that data, create the alerts, the analytics, etc. around it, but we also provide both a WebSocket and a static endpoint API for that process data with metadata such as who's got, where is that sensor in the world, and so on. And that can be sent on to any system that is enabled. Clearly, the integration will need to be done on the side of the company integrating it, but yeah, fully open. And if you want to do that direct just to the raw sensor data, then that is also possible straight with DT if you want to build your own system around it.
But if the question was if you can connect directly to the gateway, actually due to security, you can't. It is actually an end-to-end encryption. There is no backdoor, even for us. It is truly end-to-end. So it only opens up at cloud level. But we have not seen any benefits of connecting at the gateway level. So there's no APIs, there's no backdoor really on the gateway itself.
Mm-hmm. And in terms of which wireless protocols are you guys using?
So that's a proprietary protocol called Secure Data Shop. So in Europe, it operates on the 868 megahertz frequency band, open band, and for the US,
that's the industrial, scientific, and medical band. And so the reason why selecting this is because at 2.4, there is a lot of noise. There is a rock concert if you play YouTube, for example, or have a video conference like this, and then sensors can go down. And we also use less energy, and it's a band which is strictly regulated. It's more work on us, but the system is more reliable, which is what we are looking for.
Nice, yeah. And what is the operational lifetime of the sensor?
15 years is the maximum. That's at 15-minute readings, and 5 years at a 5-minute reading. So for Legionella at the moment, we'd recommend a 5-minute reading just because it gives a better snapshot. So then that will give you a 5-year battery life. Likewise for desk occupancy, typically we'd recommend 5-minute readings just for the better granularity. And I do see another question here in terms of the confidence percentage on occupancy. That is linked to that frequency of reading. So with 5 minutes, that's obviously going to be better. So typically when the next reading comes in, the occupancy will change via the algorithm. In very rare cases, it may take 2, depending on the impact somebody's having temperature-wise. But clearly, if they sit down and the next reading's not for 4 minutes, then you've technically got 4 minutes of inaccuracy. So we typically say it's about 90% over the course of the day if you start adding up this 4 minutes, but that might extend a little bit if you opted for the 15-minute sensor. So we would definitely recommend the 5-minute sensor.
Perfect. And then a question at Disruptive. Any plans to release a sensor that can measure vibration like existing accelerometer sensors do?
Thanks for the question. I'm not going to go into details on roadmap, but this is very interesting for us as well. Also, sound is actually very interesting because there is signatures that you can take from sound and convert to actual to insight on what's going on in a room. And also on rotating equipment, on HVAC, and so on. There's a lot that can be detected by sound. But just one word on that. If we do accelerometers, we do the semiconductor and the IC behind that ourselves as well. And that's a big project. So it will take a couple of years. But then we can reduce the energy consumption to 100, maybe to 300, what is out there today. And that is needed in order to miniaturize the accelerator so much. But thanks for the question.
And I know we're running out of time here, but we said just one last point I think important to make is so we as a partnership we're not static. So particularly on the Infogrid side, where we build what are called virtual sensors on top of the DT sensors. If somebody comes to us with a use case not currently being served, we will look into building a solution around that. It doesn't just have to be the use cases we're currently doing. If there is scale to it, we will work with you to build that software. We don't charge for new software development. It's all on that subscription basis. So yeah, just
I would say that has sold us and our customers many times. We just had an incident, or I would say a challenge here, with something simple as a Philips Hue light bulb that they wanted to have red or green, depending on if there had been people on the washroom or not the last 5 minutes, and flush rates and so on. And then Will from Infogrid said, this is something for us. We'll just make it happen. And there is some complexity to just these small things. And Infogrid is the company that basically just say, we solve it for you. It's us.